Howdy, all you MSM3 students. We are talking today about simplifying radicals and estimating square roots, which sounds very fancy, but I will assure you it is very strategic. What we are looking at first are that list of square numbers, and we really need to have this list of square numbers memorized and at our fingertips. So think about knowing all of the numbers on the multiplication table along that diagonal down the upper left corner through the lower right corner. 1 times 1, 2 times 2, 3 times 3, and so on. In order to simplify radicals, we need to know those numbers and have them right off the top of our head so that we're not constantly looking at lists. So in order to simplify radicals, we're looking at having something like, for example, square root of 50 and getting it into simplest form. Now, radical form means that the answer still has a radical in it. And the factors of the number under the radical, say 50, are multiplied, right? So 25 times 2 is 50. I could rewrite 50 as 5 times 10, but I'm not going to because 5 and 10 are not on our square numbers list. I'm always going to simplify by finding a number on the square numbers list. So 50, one way to rewrite it is 25 times 2. 25 was chosen specifically because it's a perfect square. So the square root of 25 times the square root of 22 is worth the same as the square root of 50. And you'll notice that I took the square root of 25 and got 5. And then I can't take the square root of 22 and get a nice friendly number. It would be an irrational number. So I leave it as the square root of 2. And the final answer would be 5 root 2. So let's look at a couple of these in action. If I want to simplify the square root of 12, I'm going to look for factors of 12 that are on our list up here. 4 happens to be a factor of 12. 4 times 3 will give me 12. So I can write this as the square root of 4 times the square root of 3, knowing that I can take the square root of 4 and get 2. And since I can't square root the 3, my simplified radical form is 2 root 3. Now 33 does not have a factor on this list. 1 doesn't help us because the square root of 1 is 1. 4 does not go into 33. 9 does not evenly go into 33. 16 does not evenly go into 33. 25 does not evenly go into 33. And now you're too high. So this one is already in lowest terms, or you could say simplified radical form. Square root of 32. Now 4 does go into 32, but it's not the largest number. We always want to try to get the largest number because we'll be done in the fewest steps. So 16 is also a number that goes into 32. 16 times 2 will give us 32. So the square root of 16 times the square root of 2 is worth the same as the square root of 32. And since I can take the square root of 16, I get 4, and the square root of 2 would just be root 2. Last of our examples is 75. We go through our list starting at the bottom. 4 does not go into 75 evenly. 9 does not go into 75 evenly. 16 does not go in, but 25 does. So 25 times what number will give us 75? 25 times 3. Since it's the radical or the square root of 75, we'd say the square root of 25 times the square root of 3 will be worth the same. And the square root of 25 is 5. And since I can't take the radical or the square root of 3, it would be 5 root 3. Now, sometimes you get numbers that just can't be simplified, like the square root of 33. And what we can do there is we can look at estimates. The table below shows the square roots of some non-perfect squares. They've all been rounded to the nearest hundredth. What do you notice about the square root of a non-perfect square? So let's first identify the perfect ones, right? 1, square root is 1. The number 4, the square root is 2. The number 9, the square root is 3. The number 16, the square root is 4. So what do we notice about numbers that are non-perfect numbers? They are rounded decimals because they are irrational. And we may have to go over what irrational meant. Irrational meant a few different things. And number 1, it goes on forever, right? You'll notice that an irrational number would be digits that take up the whole calculator screen. They also will never repeat. There's not a pattern to the digits after the decimal point. And the last thing about an irrational number is it cannot be written as a fraction. So those are the qualities of an irrational number. And when we try to take the square root of a non-perfect number, we get an irrational number as the result. To estimate estimate these non-perfect numbers, find two perfect squares that the number is between. So for example, the square root of 29. 29 is between which two numbers on the list? So a strategy that I often tell students is when they're doing anything using square numbers is to start by putting the list up at the top of their page. If you haven't memorized the list, you can create it. You just think to yourself, what is 1 times 1? What is 2 times 2? What is 3 times 3? And you work your way up the list so you have a quick reference instead of having to always look at, say, a large multiplication table if you don't already have them memorized. So I'm going to say the square root of 29 is between what two perfect squares? So 25 is the perfect square that's just below it. 36 is the perfect square that's just above it. So it is between the square root of 25 and the square root of 36. Those are the two closest perfect squares. 117, I'm going to look up here. The two closest, 100 is right below 117. 121 is right above. So it's between the square root of 100 and the square root of 121. Now, how do we use that information to estimate? The square root of 37 is between, and I usually do mine this way. I do mine vertically. Yeah. I would say it is between the square root of 36 and the square root of 49. 36 just below 37, 49 is the next one above it. So the square root of 36 is 6 and the square root of 49 is 7. That's half the battle. Can you figure out what two numbers the answer is between 6 and 7? Now you want to look at which is it closer to. So 37 is only 1 away from 36, but it's 12 away from 49. So the answer is going to be much closer to 6 than it is to 7. So I would estimate and say something like 6.1, a number much closer to 6 than 7. So square root of 62 is our next one. The number right below it on our square numbers list is the square root of 49. The number right above it on our square numbers list is 64. So I'm going to be between 7 and 8. My answer is between 7 and 8. Now 62 is 13 away from 49, but it's only 2 away from 64. So I'm going to be much closer to 8 than I am 7. So I might go with something like approximately 7.8 or 7.9. So again, very close to 8, but not 8. Last but not least on the examples here, the square root of 43 is a little bit higher than 36 and a little bit below 49 on our square numbers list. It would fit right here. And we can say that means the square root of 43 is going to be between 6 and 7. Now, 43 is only 7 more than 36, and it is only 6 more than 49. It's pretty darn close to being the middle. So instead of saying 6.5 would be exactly the middle, we're just slightly favoring the 7. We would probably go with something like approximately 6.6. The next thing is, how do we simplify radicals if we have both a radical and an exponent? So this one has both the square root and the square. And hopefully you remember that those are inverses. So square rooting 36 would give you 6. And then this little 2 on the outside would be telling you to square the result, because I'd be inside the parentheses, square rooting the 36 to get 6. And then 6 squared brings me right back to 36. Square rooting 81 gives me 9, and then if I square it, it brings me right back to 81. So I know that the square root of 78 squared, I'm going to get the answer, and then I'm going to square it, and I'm going to get right back to 78. Square root of 29, I'm going to square root it, and then I'm going to square it and get right back to 29. Now, at this point, we're going to go into estimating how to look at a radical here that's got more than just the radical with a number underneath it. And this is going to be on day 2 of the homework. So you're welcome to pause it here and finish watching the rest of it tomorrow if necessary. I'm going to keep going. You can use your knowledge of squaring square roots to estimate more complicated square root problems. Estimate 5 root 8. So if we want to know what 5 root 8 is worth as a whole number with a decimal attached to it, there is a way to do that. No one's going to walk into Home Depot and ask for 5 root 8 feet of wood, right? They're going to want to know, how much do you need? Give me like feet. Give me a decimal. Give me a mixed number. They're not going to want 5 root 8. So there are steps. First, you have to square the given amount. And you will notice over here, the first thing you'll see me do is put it in parentheses and square it. The second thing you're going to do is simplify. You're actually going to square the thing that you just said, oh, okay, well, first I'm going to square it, then I'm going to simplify that result. Last but not least, you're going to take that result and you're going to estimate its square root as a decimal. So I'm going to start with a couple sample problems at the bottom because this doesn't make a lot of sense until you see it live and in action. So 3 root 10. Step 1 is square the given amount. So the first thing you're going to see me do is put it in parentheses and square it. Now, what does that mean? That means I'm going to do 3 squared, and it means I'm going to do the square root of 10 squared. I'm squaring both parts. I have 3 times 3, which is 9, and I have the square root of 10 squared, which we just learned. The square root and the squared cancel, and we get 10. 9 times 10 is 90. So that's steps 1 and 2. Squaring the amount given and simplifying. Now we're going to go to that third step. That third step says estimate the square root of the simplified amount. So I'm going to take this and say, what's the square root of 90? That's what we did right above. The square root of 90 is between the square root of 81 and the square root of 100. The square root of 81 would be 9. The square root of 100 would be 10. Now, how close are we? We're 9 away on the left side and we're 10 away on the right side. We are pretty close to split down the middle, just slightly closer to 9. So we would probably go with something like approximately 9.4. In the middle, but just slightly closer to 9. All right, let's try that again. If we first square the given amount, I'm going to put this in parentheses and square it. So I've got 4 squared times, and I've got the square root of 2 squared. Well, we know 4 squared means 4 times 4, which is 16. And the square root of 2 squared is just 2. That means that once we've squared it and simplified it, we get 32. Step 3, estimate that square root, the square root of 32. So 32 is between the square root of 25 and the square root of 36. Those are the two numbers at the top of our page that 32 falls between. That means our answer will be between 5 and 6. Now, how close are we? I'm 7 away on the left, and I'm only 4 away on the right. So I'm closer to 6 than I am 5. I might go with something like approximately 5.7. You might go, oh, Mrs. Fraser, I did approximately 5.8. And I'd say those are both good answers. They're between 5 and 6, but they're closer to the 6 without being right up against the 6. So I would take multiple answers as long as they are logical and reasonable. So I can't wait for all your questions in class, and I'm sure that we'll end up doing some live in class as well. Have a great day.